Hi Addie, today we are going to go over like terms and then addition of like terms. And I think you're really going to like this lesson. For real, Addie. I'm looking at you right now. Addie, you want to come say hi to future Addie? Come say hi to future Addie. Danny, you come say hi to future Addie. No? Okay. Okay, fine. I'll say hi to future Addie. Hi, future Addie.
Hi, future Addie.
Okay, this is going to be great. First of all, why did the Scarecrow win an award? Because he was outstanding in his field. He was outstanding in his field. Get it? I'll let you pause for laughter right there. And then we are going to move on to like terms. Remember what a term is? A term was like a number. It could be either numbers or variables that are all together in one expression and that can be simplified down to a single number. That's kind of what a term is. So like terms are going to be terms that have the same variables in equivalent form. So what we mean by that is if you have a term that is like 6x, that is the same as a term that is 5x or that is negative 2x. Because the variable, the letter part of it, is the same. You could have a term that is different. 6x and 6y are different. Those are not the same variables, and they would not reduce down to the same number. So those are not equivalent. But you could have 6xy, and you could have 5yx, and those are like terms because it's still an x multiplied by a y. Right? We learned how it doesn't matter. You could change the 5yx to an xy and that would be fine. It would be the same thing. So those are like terms. They have the same variables in equivalent form. So let's go over some other examples. These are all like terms. And here we're adding them all together. You know what I mean, algebraic addition, even though there's a negative sign right there. And it turns out that you can add like terms as long as the variables are the same or in an equivalent form. Now here they're written in different orders. You have XMP, PMX, MXP, but you know that when you multiply it doesn't matter the order. So they're the same or they're in an equivalent form. So that's totally fine. Also, this part doesn't matter either, the negative or the positive here, because we kind of think of it as algebraic addition, right? So you could just be adding a negative 2, and we already know that the numerical coefficient in front of the number doesn't matter. It's if the variables are the same. Okay, so we only depend on the variables to tell us if those terms are equivalent or like terms, and we don't pay attention to the numerical coefficients or the signs, okay? All right, so the order doesn't matter. This is just a little proof to show you that the order doesn't matter and that these are actually, like terms right here. So here we have XMP, PMX, MXP. And they say, you know, if you were to plug in these numbers where X is 4, we'll just do it real quick. If X is 4, this would be 4 times 2 times 6. And then this next term, PMX, that would be 6 times 2 times 4. And this last expression would be if M is 2, X is 4, P is 6. And then what you're going to get is, let's do the first one. 4 times 2 is 8 times 6 is going to be 48 for the first one, 48 for the second one, 48 for the last. So that tells you that doesn't matter the order you multiply them. This is a like term, this is a like term, this is a like term. Therefore, these are all like terms. Okay, so cool. Before I show you what you can do with these, because I think you're already ahead in your mind and you're going to be like 4 minus 2 plus 6, I know that that is all going to simplify to 8mxp, because you are probably ahead of me already in your mind. But we're going to look at this adorable guy. Look at this old guy. He looks like a 2-year-old holding that sparkler, and he's so cute and happy. That just made me smile, so I thought, you know what, I'm going to take a little pause and show that to Addie because it's adorable. Okay, addition of like terms. Now you remember the distributive property, which is this. This is actually the extension of the distributive property. So if you have an A out here and then you've got a parentheses, and on the inside of the parentheses you have B plus C plus D plus whatever, then what you can do is multiply A times B plus A times C, and you get this, AB plus AC plus AD, et cetera, et cetera, et cetera. You could do that forever for what was in there. Now, if I write the distributive property just in a slightly different way, your mind is going to be blown. This is the last part of the distributive property, and then we just changed the orders. Instead of AB, we made it BA plus CA plus DA. Okay, so if you've got that going on over here, you can kind of do the distributive property backwards. Are you kidding me? Backwards. So now the A is out here. If you take out the A in all of these expressions, what you're left with is B plus C plus D plus whatever. And you can take out the A because the A is the same in all of them. The A is out here now. And it's kind of like the opposite of the distributive property. Does that make sense? Okay, let me show you how it's going to make sense when we do problems like these. When we do problems like these, what is the same? XMP, XMP, XMP. Okay, so you got this. If we take the XMP out, let me get a super bright color. This is kind of like the distributive property backwards. You multiply it by what's in the parentheses, and what's going to be left is the thing that's left out of all of these. So if I take away XMP out of this, all I have left is the 4. Okay, let's look at the next term. If I take the XMP out of that, all I have is that minus 2. Okay, and if I take the XMP out of this last term, all I have is that plus 6. Okay, so now I have an expression that looks like this. XMP is out front, and you have 4 minus 2 plus 6, and you can actually simplify that. 4 minus 2 plus 6 is equal to 8. Bam. And then you can also write this in a different way. I think it looks a little better to write XMP, like that with the 8 out front, like it's the numerical coefficient out front. Bam. Was that amazing or what? So to add like terms, we just algebraically add the numerical coefficients. I kind of did it the long way because I know you can handle it, but here's another way. Here's the simpler way to do it. You can say, aha, I see that these are all like terms. Since they're all like terms, I can add the numerical coefficients. 4 minus 2 plus 6, which is 8, and then do XMP. Bam! Even easier that way, right? So to add like terms, you algebraically add the numerical coefficients. Let's try some. Okay, this is example 18.1, and it's on page 80 if you're following along. But it just says simplify by adding the like terms. Okay, look at these problems that you're going to be doing, and you were wondering when this book was going to get hard. Oh, we're there. We are there. So here's what we're going to do. We're going to start at the left-hand side, and we see that this is 3x. Okay, now we're going to look for a like term. The only one that is alike to that one is this one on the end, 3x and negative 5x. So if I add the numerical coefficients, 3 minus 5, I have negative 2. Negative 2x. And then what I'm going to do is I'm going to cross those out because I don't want to get confused because I already did them. All right, now let's look for more like terms. This is actually a like, or this is a term, xy, and this has an xy, even though it's in a different order. It's yx. They're the same. Doesn't matter. This one, does it even have a numerical coefficient? This one? Yes, it does. You know that it does, baby, because when there's nothing there, there's a 1 there. So treat it like there's a 1, because you can multiply anything by 1 and it doesn't change it. So just pretend that there's a 1 there. So let's take that one and add them to algebraically add them. So now I have 2 minus 1 is just going to be plus 1 xy. And since there's a 1 for the numerical coefficient, I really don't need to write it because it's implied. So that's just xy. And I'm going to cross those out because I already took care of that. And the only thing I have left is this lonely little 5. And there is nothing like it, meaning that there's no other +4 or anything else that is exactly just a number. So if there's nothing like it, all we do is bring it on down, and then cross that out. And I've crossed everything out, so I know that I'm done. And this is the final answer. Let me make sure that I got the same answer as the book. Yes, I did. So one of us must be right, and it looks like both of us is right or wrong. But either way, we did it. Let's do example 18.2. And again, the instructions are to simplify by adding like terms. I actually love these problems. They're super satisfying to do. So let's start all the way at the left. We've got 3xy. I'm going to look for, the other thing I do is kind of eyeball all my terms. Like I know there's 4 terms here. Okay, so we've got 3xy. Let's find something that's similar to that. Aha, we have a yx right here and a -10. So if we add the numerical coefficients there, -10 plus 3 is going to be -7 xy. Okay, I did that. Bam. What's the next one? The next one is xyz and xyz, just written in a different order. It's yzx, but it doesn't matter. I'm going to write xyz. That's more satisfying. And then I look at the numerical coefficients. I've got a 2 and I've got a -5. -5 plus 2 is a -3. So I have -3 xyz. That sounds like a poem. It rhymes. And that's it. Look at this, baby. We're done. Was that super satisfying or what? We took this expression, which is 4 terms, down to 2 terms. Woo! Yeah, baby. All right, let's do the next one, 18.3. We are going to add like terms here. These are getting more complicated, as you can see. So we've got a 4 here at the left. Is there anything that is similar to that? Yeah, it's a coefficient here with no variables. So we've got 3 of those. Can we add 3 like terms? Is that possible? Yes, it is. Yes, it is. And it's super fun. So we've got -15 plus 5 plus 4. So -15 plus 9, that's going to be -6. And then I'm going to cross those out because I did them. All right, what do we have next? We have 7mxy and a 3mxy. I'm saying it in that same order, even though it's not written in the same order. It doesn't matter, as you know. So 7 plus 3 is 10. Plus 10 mxy. I like the mxy order. I like the alphabetical. All right, and that's it. That's my answer. Bam, I'm going to circle that, and we are good. Let's do example 18.4. We are cruising. Simplify by adding like terms. What do we got here? We got a 3x. Is there another, just a plain x? Oh yeah, there's one there. Don't miss that one. That would be tricky. And remember the implied 1. And then we've got this -3x over here. Okay, so 3 minus 1 is 2 plus a -3. Wait a minute. No, 3 minus 1 is 2. 2 minus 3, positive 2 minus 3 is a -1. So I'm going to write -1x. But guess what? Guess what? I don't need that. Whoops, I totally erased that, but I guess that would have been okay. Guess what? I don't need that 1. That's just an extra number. So let's just make it -x. Bam. And I got rid of 3 terms all in one shot. All right, what do we got left? We got a -y, which is a -1y. We got a -2y. And we've got a -8y. So -1 minus 2 is going to be -3. Minus 8 is going to be -11. Haha. -11y. Bam. Done. 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 Easy. All right, what do we have left? We've got this 5 left, and we've got this 10. We don't want them to be lonely. Let's add them together. -10 plus 5, we end up with a -5. Easy. How could you mess up on these problems? Well, the way you could mess up and the way they try and get you is to mix up signs and and which I almost did right there until I caught myself, to not know that there's a 1 in front of a variable by itself. And they might try and mix you up by switching the order of the variables, but you're not going to fall for that. That's going to be easy for you. So really, I think you're going to do awesome on these. There's one more, so hang in there. This is the last one, and then we are done. So let's start all the way to the left. I've got this -3. Are there any other just numbers by themselves? Yeah, there's a -5, and then there's a -14. So that's going to add together to -22. Okay, and then I cross those out. Done. Then my next term is xmy. Here's another xmy. So I just add the numerical coefficients, 8 plus a 1. So I've got plus 9myx. Cross that out. And then the last one is a -y and a -3y. So I know that's a -1. So -1 plus a -3 is going to be -4y. Now I want you to notice something. I got an answer that looks a little bit different from the book. They wrote it down like this: -22 minus 4y plus 9myx. Okay, guess what? I got the right answer. The book got the right answer. These are both the same answers because you can change the order. That's the commutative property of addition, and it doesn't matter. So these are equivalent, and as long as you get something equivalent that's in the book, that's totally fine. The other thing you could do differently is if you didn't write it like this, if you wrote xmy, guess what? Also the same answer, and also equivalent, and also correct. So there's so many ways that you can get the right answer that we got this. Let's go do our homework, okay? Love you, Addie. Bye.